Hello, my name is Dan Oak, and I'm a student at Athabasca University, currently taking the course COMP308, Java for Programmers. And I'm working on tutor marked exercise number 3 right now. I'd actually completed 90% of it, although maybe it was only about 85%, a few weeks ago before I took the final exam for the course. And when I went to look at it again today, I realized that it wasn't quite up to code, so to speak. No pun intended. Um, in the sense that it worked. If you watch my previous videos that I put out showing the troubleshooting issues, it worked for the most part, but then there was an issue when I restored the file. I could restore it, but all of the events just executed immediately and out of order. And through some troubleshooting and looking at it, I determined it was because when I originally created the events before the power out or the window malfunction or whatever the error was that happened, the delays associated with when the events would get executed were created then, and they never got re-updated, so to speak, when I restored the file. So you'd have to watch the previous videos to find out the full breadth of what that issue was. But basically, I think I've got it all fixed now, so we're going to just do a quick trial run and see if it works. So we're going to just recompile the code for good measure, make sure it's all good to go. And we're going to run the code with the examples4 file. Now, the examples4 file contains this information. So it contains these 11 events, and they should execute in the order as per their time. So again, this time is in milliseconds, so 2000 represents 2 seconds. So the first event that we should see execute is thermostat night event, and then the light on event at 2 seconds. Again, they're not executing sequentially in the order of the file, at least they shouldn't. They should execute this event on, then this event, then the night off event, light off event, correction, and then the water on event, and then the power out event, which simulates a power outage, should happen in 6.5 seconds. So again, after we've got the thermostat night, light on, light off, water on, and then this happens. Then when we restore the file, we should have the fans on event execute, the fans off event execute, the bell event execute, at least the first one at 9 seconds, and then every 2 seconds after that. This is going to be in a separate thread, followed by the water off event, the thermostat day event, and then after 8 seconds after that, the terminate event. So I think I've got it sorted now. So basically, after we have the power out event happen, when we restart, there should be about 7 seconds, well, exactly 7 seconds, before the fans on event happens, and then the fans off event a second later, and so forth. So let's see if that's the case. Okay, so we'll just pause this timer at 10 seconds to make it easy. Actually, just restart it. So if you rewatch the video, you might be able to see that those happened when they were supposed to, triggered. And now, when I restore the event, as you can see, we had thermostat on night setting. That event happened, so that should be gone. Light on event, that event happened at 2 seconds. That event should be off, or should be erased from the list as well. Light is off event, that happened at 4 seconds, so that event got erased from the list. Greenhouse water is on, that event happened at 6 seconds and should be erased from the list. And then the power out event triggered, which caused this whole error, power outage detected, emergency shutdown, all this stuff to happen. That happened at 6.5 seconds. So now when we restart, we should see the fans on event after 7 seconds, then the fans off event at 8 seconds, and so forth. This event will happen at 9 seconds, but then it'll happen, there's 5 rings in total. So the first ring, ring number 1 equals 9 seconds, but then ring number 2 equals 11 seconds, number 3 equals 13 seconds, ring number 4 equals 15 seconds, and ring number 5 equals 17 seconds. So, but this is the first event that should happen after 7 seconds. So, I'm going to call the dump method. So we're waiting, and at about 7 seconds, right about now, we had fans on, fans off, and as you can see, at about 17 seconds, should be the last ring, ring number 5, about now. Yep. And then terminate at 20 seconds. So we seem to have fixed our issue, which was basically I wasn't resetting. Let me just bring it up here. I wasn't resetting the timing delay. So how did I fix that? Well, I fixed it in a couple different spots. Let's look at the controller class. So the controller class, which you may remember that greenhouse controls extends from, so the greenhouse control class extends controller. So ultimately, this is where it's getting its add event method, its run method, all that sort of thing. So before, I basically was creating the event, and that's when, if we look at each event object, we see that that's where I start the event and create the timings, the delay timings, and I wasn't ever updating that. So I added this method, and you can read my little comment here in step 4. I added, the little comment says, I'll just read it here, added to solve issue associated with events executing immediately after restoring program after a power out or window malfunction event occurring. Prior to adding this method, the delay times associated with events were not updated when the system was restored. So this method solves that issue by updating all the delay events after restore. So, and we can see that that did solve the issue. So as the Doxygen, or not Doxygen, I'm thinking C++, as the Javadoc comment says here, resets the event time of all scheduled events, so they delay from now. Basically, they delay from the point that you restart the program. So if it was supposed to go off at 7 seconds, and I debated on how I was going to do this, by the way, because I'm thinking, well, if the power outage happened at 6.5 seconds and the fan was originally supposed to come on at 7 seconds, should I just have that start like half a second later? And I was thinking, you know what? For simplicity, we're just going to have it start 7 seconds from now. You could, if you were doing this on your own, you could by all means just have it start, you know, half a second later. That's easy enough to do. It's really just tweaking a little bit of the math and adding like an offset in there. I decided just to start over because the assignment wasn't super clear on that. So I just opted to restart the delay timings. But you could definitely start it, you know, you could definitely make it so that they kind of start whatever amount of time later they would have originally started based off the originals. So that's easy enough to do. I just opted not to do it that way. But the method, as you can see here, it takes no arguments in. It's a void method. Public void reset event times from now. So again, it does what the method says. It just resets the event times from now when you restore the code. And it just uses a for each loop, enhanced for loop to iterate through event list, which again is the private instance variable of this of a controller. It's just the list that holds all the events. So I'm iterating through that, pulling out an event at a time, and I'm calling the start method on the event. So this start will recalculate the event based on the current time. And I'll show you that. So each event has a start method associated with it. So here's the start method in event, and it basically just again allows restarting of the event. So it just grabs the current time using the system.currentTime millis function, which grabs the current system time, the current time in milliseconds since the program is started, plus the delay time, which is associated with the file. So that's the, you know, the 2000 or whatever number comes after time equals. That's the delay time. So it takes the current time from since the program has started executing, like the current exact time now, in milliseconds, plus you add the delay time to it, and that's the event time. That's when the event should go off. So that wasn't happening before, so we've now updated that. We've added this function to the controller class, reset event times from now, and then we basically just updated that in our restore function. So if I go to my restore function, so here's the restore function that happens when I restore the greenhouse controls after there's been a power outage or something. When you go in the restore function, now I basically do all the same stuff as I did before, which I'm not sure if I was showing you the code before. But here, after I resume and apply my call my getFixable method, which returns a fixable object, i.e. something that implements the fixable interface and therefore provides implementation for a fix and log method. Before I call the run method, which is what I was doing before, I added this code here. And as you can see from the comments, the same comment as before with the same mistakes. It basically just resets all the event timers based on now, the time now. So again, just reset the timers. So that is the fix to our previous issue. So now this should work with other files. If I was to, let's just pull up another file. Let's look at example 3. So example 3 has a window malfunction. Okay, so I'm just going to grab this. And let's do this up. So examples 3, we'll run this. I'm just going to put this over here. Okay, so the emergency malfunction seemed like it happened around 15 seconds. Let's see if that's accurate. I've not looked at this file closely before, but as we can see, we come in here, system restarting system and reading events from file, thermostat on night setting, thermostat on night setting, which happens right away at time 0. That gets removed off the list. Then light on, light off. Light on happens at 2 seconds. Light off happens at 4 seconds. Greenhouse water is on. Happens at 6 seconds. Fan on, fan off. So fan on happens at 7 seconds. Fan off at 8 seconds. Bell event rings. So the bell event rings at 9 seconds is when it starts. So bell event rings at 5 rings left, 1 of 5. That's at 9 seconds when it starts. And then 11, 13, and so forth. So again, it starts at 9 seconds. So, and then it'll happen. So it'll happen at 9 seconds, at 11 seconds, at 13 seconds, at 15 seconds, and at 17 seconds. And because the window malfunction did happen around 15 seconds, we can see here, that means we should really only see 3 rings, maybe 4 actually. The 4th one will probably happen as well. So let's look. We get ring 1, and then we get the at 9 seconds, and then we get water off at 10 seconds. That makes sense. And then ring 2, which would be at 11 seconds, and then thermostat on day setting at 12 seconds. So again, 9, 11, and then 12. And then we get bell ring 3, so the 3rd ring at 13 seconds. And then we have the window malfunction at 15 seconds. So it happens at 15 seconds, but at the same time, we get the bell ring still happens. So the window malfunction and the bell ring, and why? Because this is happening in a separate thread. So that happens. So there's really one bell left that needs to happen at 17 seconds. And so, yeah, that's what happens there. So then if I restore this, I'm just going to reset that. Now if I restore this, I get the fix. I'll probably have to wait for 17 seconds, and I should have started this earlier. So now it's going to be off, but there'll be a difference of 3 seconds between these. That's all we need to know. So when this happens, we'll know when the other thing's going to happen. It'll terminate 3 seconds after. So an interesting thing happened here. Because the bell is a separate thread, it seems like it didn't pick up. So it didn't do the final thing. It just terminated at, well, 20 seconds. So it still worked in the sense of the restore. However, the final thread didn't seem to happen for the bell. Now, probably because of the sense that when you initialize the thread initially, we initialize it, and we're not re-adding that event. We weren't re-adding all the events because it didn't make sense to. In my opinion, it made more sense to do it the way I did it without re-adding the events. However, I guess in the sense of the bell, we probably should re-add the event, or at least in that particular case, and find out how many rings are left if we want those rings to continue. Because of the fact that otherwise, as you can see, it won't happen. So that's one other thing now we got to fix. But we're slowly making progress here. So I'll just have to take a closer look at the multi-threading issue with the bell, and just to show you what I mean by that. Let's just move that out of the way. So here's bell. So again, the bell event rings multiple times at 2-second intervals and uses a separate thread to avoid blocking other events. And this bell event would have got started when we created the event, but we never recreate it. So the thread never continues. So really what we need to be able to do is store the number of rings left that there is left. Maybe store that somewhere else. Like we have variables in the greenhouse controls object. We have variables that control the error code, power OK, power on, that sort of thing. Maybe we need, maybe it would be prudent for us to store the rings left on a bell, and we could just reinitialize that thread. But that's something I'll take a look at here and come back when I've got that sorted out. But anyway, we're slowly making progress, and hopefully I'll actually just finish the 2-to-mark exercise 3 this time and move on from there.